Student, you are on to Mathematics Secret Revealed by Dr. OJ. In this video, we want to examine or want to look at a particular test that can be used to confirm the uniform convergence of a sequence of functions. Apart from Cauchy test, you also have what we call the Weierstrass M test. The Weierstrass M test. We have this Cauchy, uniform test. We have a Weierstrass M test. The Cauchy one is similar to the definition of the supremum that we used earlier in our video. But today, we want to particularly talk about the Weierstrass M test of confirming the uniform convergence of sequence of functions. Let's take the Weierstrass M test first. The Weierstrass M test states that the Weierstrass M test states that let fn of x be a sequence of functions. Let n of x be a sequence of functions. Now defined on a domain D. Now suppose there exists a sequence of constants. Let's call the sequence of constants mn, such that one, the absolute value of sequence of function is bounded by the sequence of constants for all x in the domain D. Number two, the summation of the sequence of constants, that is the series of the sequence of constants, converges. Then, if this happens, then the series of the sequence of function, converges uniformly on the domain D. Now, this is what we call the Weierstrass M test. It's a very powerful tool in confirming the uniform convergence of sequence of functions. We're going to apply this Weierstrass M test in finding out whether a given sequence, converges uniformly or not. But before we go into details, let's examine the test itself. The statement of the hypothesis says, let fn of x be a sequence of functions defined on a domain D. Our domain D could be closed interval 0, 1. Okay? Now, suppose there exists a sequence of constants. Suppose we have a sequence of constants, denoted by mn, such that sequence of function, the absolute value of sequence of function, is bounded by the sequence of constants. Then, the series of the sequence of constants will converge. That is the statement. So, now let's look at, and if the series of the sequence of constants converges, then the sequence of functions, the series of the sequence of functions will converge uniformly. Two things must happen. The very first thing is, now, the absolute value of sequence of functions must be bounded by mn, which is the sequence of constants. And two, the series of mn must converge. So if the series mn converge, it implies that the series of fn of x will automatically converge uniformly. So let's look at an example to illustrate what we meant by the Weierstrass M test. Let's use an example. I want to see how we apply Weierstrass M test in establishing the uniform convergence of a sequence of functions. Now let's look at an example. Let's look at an example 5. Now, example 1. Example 1. use Weierstrass Weierstrass is a mathematician, M Test, to check, use to check the uniform convergence of the function f(n) of x, the series of function f of n, this is x raised power n all over n factorial on half closed interval. This interval is half closed. You can see it doesn't have upper band. It doesn't have upper band. The lower band is 0 and doesn't have a definite point as the upper band. Now, how do we solve this? First of all, our fn of x is x n raised power n over 1. Don't forget, we are particular about finding the absolute value of fn of x and see if it can be bounded by the sequence of constants given to us. So now let fn of x be equals to x raised power n over n factorial. Now we consider the series. Because we need the series of this. We need it. And we equally need the series of mn. Don't forget, we have to get that. We need the series of this. Now, therefore, consider the series fn of x, like I said, as m stands from 0 to infinity, which is going to be the series of x raised power n all over n factorial, as m moves from 0 to infinity. You are wondering why did I consider from 0? Because the minimum, let me say the infimum of this particular interval is 0. So our n will start from 0. It's going to start from 0 to the infinity. Okay. Now we first find the boundedness, because we want to see whether the absolute value of fn of x is bounded by the series of the sequence of constants. Let's check the boundedness first. Is it bounded? Is the sequence of functions, is it bounded or not? Now we find the boundedness. We find the boundedness of the given sequence of functions. And how do we get that? Okay. Now for any fixed x in that domain. We have the absolute value of fn of x, is going to be the absolute value of x raised power n all over n factorial, which is the same thing as x raised power n all over n factorial. Okay. Now note that this value is always positive. It can't be negative. This value. How? If you pick your n as an integer, and you find the exponent of x raised power n all over n factorial, it will always be positive, because the absolute value of this is this. Note that x raised power n all over n factorial is always positive. Okay. With that now, so what happened? So that means that invariably our sequence of constant is that. Okay, let's look at that. Let's look at it together. So that implies that. That implies that fn of x, less than or equals to mn, is equal to x raised power n all over n factorial. How come? Fine. When you find the absolute value of fn of x, you got x raised power n over n factorial, and which is bounded by mn. So it means that your sequence of constant is the same thing as, because the sequence of function of constant given to us must be positive. It must not be negative. Because you cannot say that a positive value is bounded by a negative value. No, that's not possible. It's not possible. Okay. Now we claim with this now we claim that the sequence of our function and the series of this function converges. That same that this n as n tends to converges. Now, do you understand the concept at all? Don't worry. Let me quickly recant. Let me recast what I've said. We have defined Weierstrass M Test. We have shown that two basic things are needed. The absolute value of the sequence of function given to you must be bounded by the sequence of constants you introduced. And at the end of the day, the series of that sequence of constants must converge. You know, when we say something converges, it has a limit point. It must have a limit point. It must, Now, and if that series of constant converges, it implies that the series of the sequence of function given to you will converge uniformly. Now here, when we find the absolute value of the given function given, we obtain x per n out or all over n factorial, which is a positive value, and which implies that it complies with this. If it had been negative or otherwise, then it wouldn't have been bounded by mn. Remember, mn is a sequence of positive constants. So you cannot say a negative value is bounded by a positive value. That is not possible. Or a positive value rather is bounded by a negative value. No. So that is not possible. So with this now, we have established that this particular value as in converges because it is a product of the boundedness of sequence of functions with respect to the sequence of constants. So with this, we have come to the end of Weierstrass M Test. So see you in the next video. Don't forget, click on the notification bell so that each time I upload a video, you'll be daily notified. Thank you.